Assalamu alaikum. In this video we will understand what is Gibbs phase rule, and then after understanding the Gibbs phase rule we will practice one or two example how to determine the degrees of freedom using Gibbs phase rule. So what is Gibbs phase rule? This rule says that the maximum number of phases which can coexist in a chemical system or alloy plus the number of degrees of freedom is equal to the sum of the components of the system plus 2. Let's see the equation for Gibbs phase rule. Here comes the equation: P plus F is equals to C plus 2. Here P indicates the number of phases coexist in that chemical system, F indicates the degrees of freedom, C indicates the number of components, 2 indicates the how many variables are there. Let's see some example. By seeing this example, I think we will understand the Gibbs phase rule better. Let's see the determination of degrees of freedom. Here is a unary phase diagram given. We have to determine the degrees of freedom at point A, at point B, and at point X. So first at point A, there is only one phase is present, that is liquid phase. So number of phases present, P is equals to 1. This is a unary phase diagram. So number of components, C is equals to 1, and there are two variables, one is pressure and another one is temperature. So number of variables is equals to 2. So the equation is P plus F is equals to C plus 2. After putting the values and calculating the degrees of freedom, F is equals to 2. For the next point, point B, you can see this line is differentiating the liquidous phase and the solidus phase. So this line, in this line, the liquid phase and the solid phase will be in equilibrium. So at point B, the number of phases present is equals to 2. You can see the number of phases present, P is equals to 2. We have to determine the degrees of freedom. This is a unary phase diagram, so definitely C will be 1 and two variables, pressure and temperature, 2. So after calculating, the degrees of freedom is equals to 1. For point X, you can see the solid phase, liquid phase, vapor phase are in equilibrium at point X. So the number of phases present at point X will be 3. You can see we have put the value of P is equals to 3. We have to determine the F, unary system, so C is equals to 1 and two variables, so 2. After calculating, the degrees of freedom has become 0. So at point X, the degree of freedom is equals to 0. Let's see another example. This example for a binary phase diagram. We have to determine the degrees of freedom at copper 40% nickel alloy. That means in this line, in this vertical line, copper 40% nickel alloy at 1300 degrees Celsius, 1250 degrees Celsius, and 1200 degrees Celsius. So let's see. You can see at copper 40% nickel composition, the 1300 degrees Celsius temperature line will be hit there. So the point will be approximately here. So in this point, the number of phases present is equals to 1 because only liquid phase is present. So you can see the number of phase is equals to 1. This is the binary phase diagram. Two components are present, one is copper and another one is nickel. So number of components, C is equals to 2. This diagram has been constructed over a constant pressure. So pressure is constant here, only one variable is present, that is temperature. So variables is equals to 1. So after calculating, after putting the values of P, F, C, P is equals to 1, we have to determine the degrees of freedom, two components and one variables. So after calculating, the degrees of freedom at 1300 degrees Celsius is equals to 2. At 1250 degrees Celsius, approximately the point will be here. Look at my cursor. So here in this region, in this darker region, the alpha phase and liquid phase, solid phase and liquid phase, both are present. So the number of phases present at this point will be 2. So number of phases present is equals to 2. This is the binary phase. So number of components is equals to 2, copper and nickel. Variable, only temperature is variable, pressure is constant. So variable is equals to 1. After putting the values in Gibbs equation, we can determine the degrees of freedom. F is equals to 1. again at 1200 degrees Celsius, the point will be approximately here. So here also only one phase will be present, that is solid phase. You can see we have put the value of P is equals to 1, 2 components and 1 variables, and the degrees of freedom at this point will be 2.